So, what is happening in this picture, and how do we think this relates to today's lesson? We have Gabrielis, the natural resource in brackets, ore, is being smelted into something usable, the ingot. Okay, nice. So we're all along the right track, but I will say the keyword is smelting. Now, there is one thing that is missing, however, here, or it could have been used. Maybe they've run out. Can anybody tell me a potential resource that could have been used here? Very important when it comes to okay, cool, nice. Very important when it comes to understanding one of the later parts of the lesson. Fuel, okay, nice. Gold, not quite. Wood, sticks. Okay, great. So, moving on. Our objectives today, we need to know what is meant by renewable and non-renewable resources, given examples. We need to understand what recycling is and why sustainability is important. Sustainability is something that's going to come up a lot, especially during your lifetimes when it comes to politics and just general well-being. And then we need to be able to justify the use of different extraction methods, given advantages and disadvantages. So let's just get started. The Earth naturally produces resources that are used on a day-to-day basis. They don't just pop out of nowhere. Now, the simple things such as water that we drink, land, building materials, minerals, and fossil fuels. Now, for the most part, what we need to know is that they're going to fall into two very important categories: renewable and non-renewable. So, let's get started. Renewable resources. Have you heard of the word infinite before? And do you know what this means? Maybe someone could type in what they feel like it could mean. Okay, great, Teddy. Okay, never ending, everlasting. Some very fancy words. Okay, don't run out. Okay, that's nice. Brilliant. Now, apologies if this isn't very clear on the side, but I'll just go through each of them. So we have solar energy, biomass, wind energy, geothermal, and hydropower. Now, these are energy resources that are replenished and not exhausted. So I know when you think of the word exhausted, you think of tired. However, in this circumstance, that means they're not permanently used. So they can be replaced just as quickly as we use them. Now, they're also sustainable. Remember that key word that we spoke about in our objective. They often have less of an environmental impact compared to non-renewable resources. So the biggest environmental impact that you see a lot is global warming, climate change, and that's caused by a greenhouse gas called carbon dioxide. However, they do usually produce less energy compared to non-renewable resources. However, it's still very important to remember that they do have benefits as well as disadvantages. So I will keep the screens up for roughly 45 seconds to a minute, just for you to take any notes. Any questions, we'll try and save them for when we're doing our questions. There will be little checkpoint questions per each. So just keep them nice and ready. Cool. So I know there's a lot of information to take in on this screen, but we're not going to look at all of this, okay? What we are going to do is have a look at some of the advantages and disadvantages. So on this column here, what we have is how that energy is used. Here are the advantages, and on the right are the disadvantages. So let's take solar, for example. Just without looking at this, does anybody think they can maybe tell me what they think an advantage of solar energy might be? You might see them in houses nowadays with solar panels on top, and who knows what they'll be able to do with them later on. Okay, it's never ending. What do you mean by never ending? They look cool. Okay. Not necessarily an advantage in terms of an energy resource, but okay, more aesthetically pleasing. You can sell back electricity to the electric company. Sadly, we're not making money out of this. There's lots of heat and light outside, which means more power. Okay. Give people less time on electronics. Okay. Pay less. Doesn't affect the environment. Nice. I like the idea of paying less, but you have to be very careful when you use that, because are they free to set up? They're not. They're very expensive to set up. Now, that's where you can see with the disadvantage here. Manufacture and implementation of solar panels can be costly. However, I believe someone said it, once they're set up, they're cheap to maintain. And I do like that word. So let's have a look at something like wind. You can find it singularly, but usually many together in a wind farm. And you may have seen that when we're driving along certain roads. Um, it is potentially infinite, but downsides is that, say if it's not windy, you're not going to be getting a lot of energy. So we can say they're a bit unreliable. And usually you need a very good geographical location to place them. We're quite lucky. We're an island. You can usually see them a lot on coastlines where it's very windy and it can help greatly. So let's move on to non-renewable resources. You may have seen infinite before, but you may not have seen finite. Now, some examples of them are fossil fuels, coal, natural gas, and nuclear. Now, this is a bit of a tricky one that sometimes people get a bit confused about, okay? So these are resources that are exhausted when used, and they take a very, very long time to replenish. Some of them can take millions of years to replenish. And what we're going to be seeing soon is that that is not very good compared to the rate at which we're using them. Now, their sustainability is dependent on use. And like I said, we're currently using them at rates which are not sustainable. So unlike renewable, they usually do have environmental impacts, so such as the release of greenhouse gases, such as carbon dioxide, which can lead to global warming and climate change. I'm sure we're very much aware that this is happening in the world today, but hooray, they produce a lot of energy. So these are very important types of non-renewable resources that you need to know, and these are the ones that are going to come up more often than not. So fossil fuels, they get their name from the place where we get them from, fossils. Now, I know when you think of fossils, you think of just dinosaur fossils, or you're more inclined to think of that, but everything can have a fossil if it's a living organism. So coal, oil, and gases are the energy sources that were formed millions of years ago. Oil and gas are made from the fossilized remains of sea creatures, whereas coal, the things that a lot of you said were missing in that original Minecraft picture at the start, are the fossilized remains of trees. So two types of fossil, but they're all come under that umbrella of fossil fuels. Now, these are non-renewable. This means you cannot use them again. If I fill up my car with petrol, I have to go and fill it up once it has been used. It will not magically regenerate and replenish its stock. So remember, the three fossil fuels are coal, crude oil, natural gas. You'll see crude oil being said as oil, essentially the same thing for now. So a little quiz. What I would like you to do in the chat, I'm going to show you an image of a resource. Now I want you to do one thing, no, three things actually. The first is state if the resource is renewable or non-renewable. 2, give one advantage. And 3, give one disadvantage. I can ask if someone has just come in with their mic on, please make sure that it is muted. Okay, we very clear of what we need to do? I'll repeat that one more time. So you'll see an image. You need to state if the resource is renewable or non-renewable, give one advantage and give one disadvantage. Okay? Good. So, first one. So type in the chat. 1, is it renewable, non-renewable? Give an advantage and give a disadvantage. I'll give you 45 seconds to a minute for each. Okay, Teddy, I like where you're going with that doesn't harm the earth, but what do you mean by that? We can extend that a little bit further. We have a disadvantage. It won't work if there is no sun. Fair point. It isn't cheap. Okay, Jake, same thing. It isn't cheap. Is the sun cheap? Or is it the setup? Good, nice, Joel. Costly to set up. Good job. Harry only works during the day. Okay, nice, well done. You all got that this is renewable. A nice advantage is that it is the energy itself and the fuel is free, but a disadvantage, the installation is costly. Coal. I will say with solar as well, a lot of you mentioned that during different times of day, you may get different types of energy output or different amounts of energy output. That is also a very good point. Okay, non-renewable, great. Okay, nice. A lot of people talking about that they will run out at some point. Think of maybe a word that we can use. It begins with an S. Or Hannah, I like that word, efficient. They are very efficient. Okay, great. So this is non-renewable. They do produce a lot of reliable energy. However, they are finite. They will run out. Now, I believe someone did say toxic to the environment. Okay, can we expand that a little bit further? What gas do they produce? Yeah, good job, Jake. Carbon dioxide. Well done. Nuclear. You've all seen your Simpsons episodes, hopefully. I'll give you a hint. Think of the fish. Okay, so we've got two people saying, three people saying non-renewable. Can we think of some advantages and disadvantages? Radiation. Is that an advantage or disadvantage? Okay, nice little hand. I like that. Waste is hard to get rid of. A low carbon output. Okay. Oh, nice. I was wondering if someone would say that. Past accidents. Okay. There's one very notorious accident that happened in Ukraine. Could have a nuclear fallout if not careful. Chernobyl. Well done, Marietta. Really nice. Okay, so this is non-renewable. I think we all got that, which is very good. An advantage, again, produces a lot of very efficient energy. Disadvantage, not necessarily the CO2 production, because there's no coal, there's no carbon store in there. However, nearby fish have mutations. I'm glad you remembered that from The Simpsons. Yeah, it can be very, very, very damaging to the wildlife. You have to be disposed of very, very carefully. And if something does go wrong, there have been events in the past, such as Chernobyl, which have led entire areas of land being inhospitable, so animals and wildlife cannot live there. However, very recently there have been a lot of signs that new wildlife that have become immune to the radiation or adapted to the radiation are starting to live there. So that's very cool. Maybe check that out with a bit of extended reading if you fancy that. Last one, wind. Okay, Marietta. So is this renewable or non-renewable? We have a lot of renewables coming in. Great. Remember your advantages and your disadvantages too. It's very, very important that you need to argue that. An advantage is that it is infinite. What does that mean, Jake? Considered ugly by or Hannah. It's so considered ugly by many. There's a we call that visual pollution, and that is a very valid point. Can break down, won't run out. Easy to maintain, it's expensive. Now again, remember when we're saying it's expensive, what is expensive? Because wind is free. Won't work without wind. Okay. Yeah, nice. I like that, Alfie. Reliable. Yeah, good. Very nice, Rosie. Expensive to build. Good. Okay, nice. So these are renewable. The advantages is that they are Hmm. The fuel itself is free, okay, but the setup is very expensive. Now, you have to be very careful because it is very geographically dependent on the place in which you put them. If you're putting them or setting them up and the big farms, which are very expensive, in an area where there's not a lot of wind, your output may not be at its maximum. It won't be as efficient. Okay, good job. So recycling, we've seen this many, many, many times. So what I'd like you to do, can you list in the chat some materials that you recycle? Try yourself at the other one. What is the difference between recycling and reusing? And the challenge, in your opinion, do you think recycling is necessary for our planet? Could we get away with not doing it? Plastic, paper, okay. Is that it? Glass, metals. Okay, wonderful. Now let's move on to the second one. What is the difference between recycling and reusing? Tin, okay, nice. Very good. Paper, cloth, metal. All very good answers. Turning back into the So we got Gabriella saying recycling is turning it back into the raw material to be reused, and reusing is to use something again and again. Okay. Recycling, you're remaking it, while reusing, you're just using it again. Okay, let's have a look. Recycling means to take something and make something else with it, but reusing is just to use the same thing. And at all, reusing is using the same thing in its given form, but recycling is turning it back into raw material. Okay, so we're along the right tracks, which is good. Reusing is fairly straightforward. You're just going to reuse the same material. Recycling, we're going to learn about that in a little bit more detail. Now, just in your opinion, do you think recycling is necessary? Do you think that we could get by without doing it? Or do you feel like this is now something that is essential, not necessary, essential in the current day? Some really good answers, guys. I'm very impressed. Very impressed. Essential. Okay. Not essential. Okay, so we've got a bit of a disagreement. Gabrielis, why do you think it is not essential? It would help, but not essential. Okay, so a lot of people are saying essential. Some are saying it's not necessarily necessary. Reduces landfill. That's a really, really good point, Maria. A really good point. Reduces landfill is something that some people often forget when it comes to their answer. It is essential because otherwise the landfills would be full of rubbish. Good. Okay, nice. So to keep with demand. Some really good answers, guys. So recycling. Types of material, your paper, glass, metal, and plastics. I just want to make it clear that this is like a plastic bag, and the reason why it's there is you see this a lot, especially with certain company slogans such as Bag for Life. You're going to see that a lot. Now, recycling is the reuse of old materials to create new materials to improve sustainability. Again, we're going back to that word sustainability. Now, I haven't asked for your opinions on what you think sustainability is, but we will be getting to that very soon. Now, the three R's is what we need to know. Reduce, reuse, recycle. You may see them in different orders, but they essentially, you're going to see them as the three R's. Okay. So quite simply, reduce, lowering the amount of waste produced, and it lowers the number of resources we use. Reuse something. Many materials can be used more than once. You've all seen it with your plastic bottles and your plastic bags, but we're seeing a lot more nowadays where you've got your chili bottles, and essentially that's just to reuse. And recycle. It's using previous materials to remake new ones. Okay. All clear on that one, fairly straightforward. Now, what I'm going to do is just show you a very quick video. There'll be subtitles on there. I'll play it through twice. There'll be an activity after where you need to put what has happened in order. This relates to the recycling of aluminium. Now, you may have heard of words such as aluminium ingot before, but we need to know how they're formed and essentially the process in which they undergo so we can recycle and reuse them again for your nice Dr. Pepper and Coke cans, and my personal favorite, Fanta Fruit Twist. So let's and this video and I'll play this. Okay, very quickly, guys. Can we see the video on my screen? Sir Sprite is the best. I wholeheartedly disagree. Wonderful. So I'll put subtitles on there. Okay, whoever has their mic on, could you please turn that off? Thank you. So again, you won't be able to hear it. Unfortunately, we just got some audio issues. I will put on subtitles and I'll play it through twice. Okay, wonderful. I'll play that through one more time. Okay, so let's go back to our PowerPoint. There we go. Now you have these. What I'd like you to do is place them in order. You can put that obviously in the chat. I'm going to give you about 2 to 3 minutes to do it. Let's see how this goes. Again, if someone has their mic on, could you please turn it off? That's going to be very distracting. So Marietta, maybe try and do all of them in one go, because otherwise it's going to get very confusing trying to keep track of everything that you're doing. So again, 2 to 3 minutes. If you do finish early, maybe start thinking about what we mean by that word sustainability and why I keep referring back to it because of its importance. So again, if anybody's joined late, I'll just make it very clear. We just watched a video. Unfortunately, if you've missed the video, we can't play it again. However, this is in the relation to the formation and of aluminium ingots and how we recycle them. So all you need to do is, using the letters on the screen, place them in the order in which you think that the process occurs. So we have Alicia, GBEHD8FC. We have about 1.5 minutes left. So we have Teddy and Atul coming in with the same. Nice. Okay, so very common answers. Okay. Just give it about 45 more seconds. Again, if you're finished, just start thinking about what that word sustainability might mean and why you think I'm alluding to it a lot. Because again, it's a very, very important word. That's why it's one of our objectives. And hello, Glana. Nice to see you. Okay, 15 more seconds. Okay. So let's have a look. So first, an aluminium can is washed and put in a recycling bin. It is then collected and taken to a recycling factory. The machine shreds the aluminium and removes any decoration. Now these are melted in a furnace. You've probably seen a furnace again. We're going to relate it to Minecraft because video games can be right about science. The liquid aluminium then cools and freezes in a mold. Now that mold is now called an ingot in its solid form. Now this is again heated to 600 degrees and it becomes soft. Again, it is not liquid, it just becomes soft. That means that now we can mold it using rollers into thin sheets that can be used to make new cans. So maybe your Dr. Pepper can was once a Coke can and it all had to go through this process. So let's just go through. G, B, E, H, D, A, F, C. Well done to a lot of you because I see that was coming through very, very quickly. Now if we just scroll up, who was the first? Well done, Alicia. Really good job, guys. Really good job. So again, sustainability. This relates to the resources that are being used at a rate in which they can be replenished. Now, again, replenished means being created again. Now, fossil fuels are a really big talking point. I said that earlier. They're three that you have to know off by heart. Can anybody type in the three in the chat, please? Where, or the name of the three fossil fuels, please? Very, very crucial that you know these. So 3 fossil fuels. What are they? Crude oil, coal, and gas. Okay. Coal, oil, gas. Okay. You may see gas called something else. There's usually a word that may follow it. Not follow it, sorry. There may be one that would be before. Yeah, good, nice. Natural gas. Good job. Yep, coal, crude oil, and natural gas. Now, if we cannot sustainably use them, we must look at other alternatives. So you've probably seen this in today's news, or when I say today, I just mean this current timeline that we're in, is looking at maybe electric cars. There's certain cars that may be using hydrogen gas for engines, or they'll be looking into research for that. Now, what is quite crucial is this right here, as they will not be there for future generations. Now, you are considered a future generation. This is why you're learning about this. Generations such as mine or other teachers, we've also learned about this, and it's so, so important that we could obviously make life worse for future generations. We don't want that. Teddy saying they could blow it up. Well, hopefully that's what the research will stop. So what I have for you on the screen is how much is left for probably people born around 2010. However, this is relatable to anyone in the current timeline. Um, Now, the bold, larger lines are years remaining if production continues to grow at current rates. So what that means is if we keep using them and the demand keeps increasing like they are, then when will they be used up? Whoops, sorry. When will they be used up? So if we have a look at oil, petrol in your cars, if we continue to do what we're doing, they will run out by 2045. So if you're very quick at maths, you'll realize that that is your 25 years until your oil will run out. So you will not be able to drive petrol cars anymore. Coal, 2055. Gases, we'll say that's about 2048. And uranium, 2042. Good question, Orhan. What is the smaller line? The smaller line is if the rate of production or the rate of use remains as it would be right now. So the larger line is if it continues to increase at the rate as which is happening. And the smaller line, if we was to stop the rate of use right now and we kept it at that same rate, when would they run out? So just have a look. There's a lot of things here, such as gold, your lovely jewelry. This you might see as slightly worrying. Is there any questions regarding this, or is there any shocks? For me, this is quite shocking because it may seem like it's a long. Um, Sorry, Gabriel, I'm not entirely too sure. I'll find that out for you. However, well, what I do think is that it's quite shocking at what time these will run out. So gold, your lovely jewelry, 2030, or just above that, so 10 years. Silver, not too long. We're looking at 7 to 8 years, and zinc. Uh, well, it's slightly worrying. Does anybody else have any other opinions or any thoughts about this? For me, it's quite shocking, personally. Just while we're looking to see if there's any opinions, I'm going to have a look at that question, Gabriel. Okay, so that is, Gabrielis, in answer to your question, that will run out in roughly 15 years. And that was posted on 2014. So you're looking at about 9 years. What happens if we run out of fossil fuels before then? Who knows? Who knows? We're going to have to look for other alternatives very, very quickly. These are not sustainable. Should we invest? It depends what you mean by invest. But what I'll say is this is more science. I'm not. Well, what I mean by my thing where I say about that, Gabrielis, is do you mean invest in finding other alternatives? No, it should not fill your room with it. Okay, so if you kept the materials that run out, when they run out, would you be able to sell them? Um, that depends, because remember, they are finite. Once they are used, that is it. So their value may increase. However, it's not really doing the world any good. It's better that we look at alternatives such as wind, solar, geothermal, hydroelectric, and so on. So what I'd like to do now, can you give 3 reasons to explain why it is important to recycle aluminium? So Orhan had a question. When they run out, I doubt the value would increase, but I hold it. Yeah, exactly. So answer in the chat, please, guys. Give 3 reasons to explain why it is important to recycle aluminium. So the key word in this question here, your command word, is explain. I don't just want how you're going to recycle. I mean, why is that beneficial? So 3 reasons, guys. Maybe put them all in one answer. Okay, Gabriella's put so we don't have to make more. Um, in terms of making, everything that we use is already in the earth. You extract ore, and it'll be going back to that Minecraft um, ideology very, very soon. So maybe not necessarily to make more. Um, it's what you'll be making it with. So again, I'll give you just another minute. Why is it important to recycle aluminium? Maya saves energy needed to make the metal from raw materials. Okay, that's a really good point. That's a very good point. Come on, I know there's a lot more people. Let's get a bit more active. So it helps everyone sharing ideas. You should recycle aluminium because it is reusable, which means you can use it over and over again. It is sustainable, which means that it's produced at a steady rate. It is easy to maintain and create. Okay. See, the one question I haven't asked is, are metals renewable or non-renewable resources? As it is on the verge of running out, and if we don't reuse it, it will run out. It saves money as it is cheaper than mining. Okay, that's a very strong point. Lowers emissions as trucks don't have to transport it if it is recycled locally. That's a very, very strong answer because you thought about the outside factors. Orhan, very, very good. You do have to take into consideration those small things that you don't think will have an impact, but they do. Yeah, the transmission of these metals through trucks, it releases CO2. And as we all know, that's not good. So increase the value as you get more out of it. Maybe stop thinking about value in the sense of supply and demand. That's more economic. We're thinking of the scientific value. We're not trying to make money out of it. We're trying to save the planet, essentially. Saves energy. Also, we can reuse it over and over again. Okay. We need to recycle aluminium because we need to be more sustainable for relatives in the future and we won't run out. Nice thinking about future generations. There'll be less landfill because you are reducing the number of wasted aluminium products, saves costs and energy to make another product, and reduces gathering products by mining. Okay, so there's a lot of strong answers, and I'll pick out some of my favorites there. Um, one of them is going back to the idea of uh, one of them is going back to the idea of transport for materials. You do have to think that materials don't just magically appear in shops. Okay, you don't have to go to your Asda's, your Tesco's, and they all just magically there. They have to be transported there. Now, if we can reuse that material, it saves a journey, which is very good because remember, they will obviously produce and release greenhouse gases during transport. Cost as well. Mining does release chemicals. You require energy, electricity to power tools used for mining. And I did see a couple of answers in that, which is very, very good. It's more economically and environmentally beneficial. Yeah, I do like that. So again, economically, it is more expensive to dig up raw materials such as your ores. And yeah, environmentally, when you're digging up ores, there is always the electricity that you have to use from the machines that you're using. And again, they need to use a fuel because all of this doesn't just appear. Okay, great answers, guys. Nice. But I think there's one thing that we do need to remember is that the ingot isn't just the ore. You're going to find ores as something called metal oxides, sorry, more often than not. And an ore is a naturally occurring rock that contains enough of a mineral to make it worth extracting. You've probably seen ores in Minecraft or any other game where you have to gather resources. Now, what is here in this time? Oslo, you have a question? Okay, I'll just carry on until the question comes through. What we do have here is the coal, okay, which is very, very important. Now, ores are extracted from quarries or mines. Now, after processing, the metal is extracted. Now, what is very important to know is that we only want the metal from the ore. So if we have a look here, maybe some of you can enlighten me on this one. Is this iron? I believe it is. Iron ore will be iron oxide. Now we only want the iron from there. Oh, great. I'm glad to see my Minecraft knowledge is up to scratch. Now here we use iron ore and we want to extract the iron. We only want that iron to form an ingot. You may have seen something called the Reactivity Series in year 7. Now, I like to teach it with a very fun song. So what I am going to do is find the link. Let me move this away and place it on my second monitor. And what I can do in your spare time, I will provide the link in the chat. Or if you go onto YouTube and you just type in the Reactivity Series song, this is a nice way of learning the Reactivity Series. And it's very, very important in understanding how we extract our metals. So from top to bottom, oh, there should be a 15 next to platinum. I just realized, my apologies. The top is the most reactive compared to the least reactive. Now, there is a line here for a very important reason. Now, before I go into any detail about this, does anybody know why I have put this line here? You don't have to watch. It is something that you can maybe do after if you'd like to learn more about the Reactivity Series. It is a very fun song. We do have this here for reference. And yeah, I will say the song may distract you for some very important parts that are coming up. Is it because you're segregating the groups in the periodic table? Good guess. It goes from most reactive to least reactive. See, we know that it's going from most reactive to least reactive, but why do you think I've put this line here? It's a different area of the table. Separate metals from non-metals. Okay, so all of these are metals, but so are these. Okay, the only one that isn't a metal is a carbon, and I've specified there. I will say the idea of segregating the groups into the periodic table, not necessarily entirely true in relation to this, but it's a good idea because those metals above the line are renewable. Sadly not. Good try. I'll take one more guess. I will say I'm very impressed with some of the answers that are coming out. It's very clear that some of you have done some background research or background work in this. Nice. Okay, it's looking like we haven't got another answer, so I'm just going to move on. Okay, this line will separate the two different methods that we need to know about. Okay, until the late one. The metals under the line are transition metals. Okay. Is it the timing they'll run out? Okay, so some good ideas, but I'll just make it very clear now. This line will separate two different techniques that we use to extract them. Now, going back to that Minecraft image, which I'll go here, this is very, very important because coal, when burned, releases a certain gas. Now, let's go back to this. What gas is released? Good. Jake's the first one in there, CO2. Carbon dioxide. So it has to contain carbon. Now, we use what we call a displacement reaction for this. So in the example of carbon and zinc oxide, what we want to extract is the zinc. The carbon will be produced by a fuel, such as any sort of wood material or any coal. Anything that contains carbon can be used in this situation. So first, what we're going to do is look at your reactivity series. Is carbon more reactive than zinc? So I'll just give you 5 seconds, 10 seconds, just have a look. Is carbon more reactive than zinc? Yes or no? Okay, that's all with yes. Teddy with yes. Nice, a lot of answers. That's what I love to see, guys. A lot of activity. Good job. Okay, yeah, you're right. Carbon is 100% more reactive than zinc. So there's a rule that we can follow. If it is more reactive, it can displace it and a chemical reaction will occur. If not, it cannot displace it. Now, I'm just going to focus on this keyword here, displace. Notice how I'm not saying replace. If you displace something, think of it as the equivalent of sitting in a chair at school. Someone comes and sits in your chair, and then you're just standing along the side. You're still there. So what will happen is carbon dioxide plus zinc oxide, we have now extracted the zinc. Now, here's the downside. We also produce carbon dioxide because remember, in chemical reactions, you do not create or destroy, you just rearrange. So that carbon will be used. It will chemically react with the oxygen to form carbon dioxide. Now, again, what can this lead to with the release of carbon dioxide? I'll say that again, guys. What can the release of carbon dioxide lead to, which is harmful for the planet? Okay, global warming, nice. Now, what can global warming lead to? Okay, so carbon dioxide is the greenhouse gas. Okay, carbon dioxide is the greenhouse gas. Nice. Climate change and global warming. So global warming can lead to climate change. Okay, death, very extreme. Right. So what I have here is some examples. Now, what I am going to do is just very quickly just run you through like the little steps again. So look at your reactivity series. If carbon is more reactive than the metal, it can displace it. If it cannot, it will not displace it. Now, there will be a question where it tests your comprehension of this. So we'll see how you do with that. What I will say is if you do have a bit of pen and paper, that will probably be easy to do this. However, you can just put them all into the chat with just do the products for now. Okay, we won't do the reactants, just do the products. What I'd like you to do is finish off the equations. I'm going to give you about 3 to 4 minutes to do this. Maybe we'll do it a little bit less because I feel like this is one of those concepts that when you get it, it will come very, very quickly. Okay, so let's go with 3 minutes. If you have any questions, guys, or if you're feeling a little bit stuck, feel free to put them in the chat and I'll get to you. Gabriella, so I'll answer your question at the end.
Hold it for a while, so.
Okay, guys, remember if you do have a question, please put it in the chat and make sure that mics can be muted because that can maybe distract others. Thank you. Okay, I do apologize if I get these wrong. What I'll say is, oh no, I did see your answers there. Maybe take a look at question 4 again. Okay. Give you another minute and a half. Now, what I'll say is with question 4, if you're feeling confident with your answer, I will be asking you to explain why you think that is the case. It's very nice that I can see some of you have understood it, but what I want to know is why. Maybe don't type that in the chat just yet, because we're going to go through these individually. I can see a very common mistake in one of the answers. Now, remember, how many oxygens are there in a CO2 molecule? How would that be written in word form? Not quite, Harry. CO2. "30 more seconds and we'll go through." Okay, nice. Okay, great. We'll finish up there. So, carbon plus tin oxide. If I could click on the right screen, that'd be great. We'll create tin and carbon dioxide. Keyword, we have extracted the tin, but it has produced carbon dioxide as well. The mistake I saw was people saying oxide. Okay, this is dioxide. Di means two. Carbon plus iron oxide will create iron plus carbon dioxide. Carbon plus lead oxide. Lead plus carbon dioxide. Yep, Teddy, give it a go because I'm just going to go through now. And carbon plus aluminium oxide. I've noticed that a lot of people have noticed that, so very good if you've done this. It will create aluminium oxide plus carbon, so nothing's changed. It doesn't matter which way, or which order in which they're placed in. Now, can anybody tell me why number 4 remains the same? I'd like you to explain, please. Think of some key terminologies that we can use. Oh, no, aluminium is more reactive than carbon. Yeah, that's that is pretty much the answer. Nice. So what can it not do? What can it not do so it doesn't get displaced? Nice, well done. That's exactly what I was looking for. Because aluminium is more reactive than carbon, so it doesn't get displaced. Good job. Okay, so I'm just going to leave it up there. Just make sure that you're checking everything. Very careful, Mary. With that there, Maria. You said aluminium is more reactive and it displaces carbon. Carbon is not displaced here because aluminium is more reactive. It means that carbon cannot displace aluminium, not the other way around. Okay, so in this circumstance, it's not zinc displacing carbon, it's carbon displacing zinc. And then in this circumstance, because this is more reactive, it cannot be displaced. So, for some reason, I've done that again. Now, there was the line, and we have to think about if that's the case, we see aluminium cans everywhere. So, how did we actually get that aluminium to begin with? It's an interesting concept to think about. Now, there's one thing that we have to know is electrolysis. Now, this is quite a higher level concept, but I'll go through it as well as we can and try and make it a bit more broken down. So, electrolysis is using a molten solution or a dissolved compound in water and essentially ions, which most metals are. This means they are positively charged metals. Okay, so they'll have that little plus sign like you would see with protons. They will go to a piece of metal, okay, your nodes, and this will be the cathode. Okay, so you can see here as a negative symbol here, whereas your negative non-metals will move to your anode, which is your positively charged node. So let's use the example of aluminium oxide. Aluminium, when dissolved or molten, will be a positively charged metal ion. Now this will move to our cathode to separate it. You will see aluminium only on this, so we have extracted the aluminium, whereas the oxygen is a negatively charged ion, and that will move to the anode. So we have separated aluminium and oxygen to either node based on their charges, because remember, opposites attract. So if I have a positively charged material and a negatively charged material, they will attract, whereas same poles will repel. Now, I would recommend to maybe read a bit more about this, but what you do need to know about this is that it requires a lot of energy. It is very expensive. So we try not to do this as much as possible. That's why recycling is very, very important, rather than just digging up um, or mining for some new aluminium ore. Think about it, using the machines which use electricity, which will come from factories which will use fossil fuels. The transport of those materials, again, using fossil fuels, the process to extract it will require electricity, again, fossil fuels. So although it is essential to get things such as potassium, sodium, calcium, magnesium, and aluminium, it's very important to recycle and reuse. So we're coming to the end of the lesson. A factory that primarily uses coal wants to change their ways. We're going to tie in all that we've learned today and hopefully get some great answers here, which I'm sure we will. So what I'd like to do is A, describe the issue with the fuel they are using. B, describe an alternative energy source they can use and why it is beneficial. C, what other practices could they do in their factory, just in their workplace, to improve their environmental impact? And the challenge, this company uses a lot of displacement reactions to obtain metals. How might this impact the climate? So you may need to think a little bit deeper for this challenge question. So there will be some long answers in the chat, but we just put them as A, B, C, And then maybe if you want to do D just for the challenge, you can, or if you want to put challenge, just make it very clear which answer is which. And I'm going to give you about 5 minutes to do this. We'll go through, and then that should tie us up our lesson with good timing. So 5 minutes, guys and girls. If there are any questions, please feel free to put them in there, and I'll help you to the best of my abilities. So 5 minutes. Okay, so we have an answer already. Let's just have a read through. Okay, Gabrielle, so I'm going to challenge you to extend that, especially A and B. I'm going to challenge you to extend that and make it, take it a bit further. What are the implications of that? Why is that a negative impact? And again, remember for B, why is this beneficial? So you've described, but we need to extend it. Why is this beneficial? Very important for your answer. Okay, how could they get those metals without using displacement reactions? Maybe think about a particular form of repetition that we learned about earlier, one particular letter. So Oslo, if you're unsure, what are you unsure about? But just as an overview, a factory that's using primarily coal wants to change their ways. So what is the issue with the fuel? Describe an alternative energy source, why it's beneficial, and what other practices could they improve on? And Gabrielis as well, try this challenge. I think you can do it. Don't just limit yourself to the 3 questions. So you have just over 2 minutes left, and I'd like to start seeing some answers. Apologize if I got the name wrong. There's Zifa. Okay, it looks like our message is being removed. Yeah, as if that's not me who's doing that. Try again, please. Not too sure why that's happening. If it does it again, I'll look into that. Again, guys, if you see an answer in the chat that you agree with, it's always good to put like a thumbs up next to it. That makes it very clear to me. It's a nice bit of peer assessment there. Or if there's maybe something that you disagree with, maybe you can put maybe like a thumbs down and explain why you disagree with it. It's a really good way of just peer assessing and just making sure all of our ideas are at the top of their game. Okay, I've just seen a very nice keyword describing A, which is very good. Okay, let's mute you. So again, 30 more seconds. I haven't seen many people try the challenge. Maybe try this. It's a very, very good way of uh, don't worry, that was just someone's mic who was on. I had to mute them. Okay, 10 more seconds. Okay, let's go through. So, A, the issue with the fuel that they are using, which is coal, it is not sustainable as it is finite, or the rate at which we're using them is not sustainable. I do like it where it says it produces CO2. Now, I believe that someone else took that a bit further. Alfie, very good. So the fuel they're using, it produces CO2, which can impact and have an influence on global warming and is destroying our planet as it is a greenhouse gas. So any of those, very good. B. Okay, again, guys, any mics, please just mute them for now. So B, we need to describe an alternative energy source. Now you could have had wind, solar, geothermal. Now these are beneficial because the fuel source is free. Okay, they may not be the most efficient, but they are free and they have less environmental impact. So C, what other practices? So we just had a question. I don't really know if this is, but can displacement reactions cause the caves to warm up, which could cause hazards like landslides? I don't believe so, though. I'll I'll check that. But as far as my knowledge goes, no, I don't believe so. C, what other practices could they do to improve their environmental impact? Remember your three R's: recycle, reduce, and reuse. These are general things that not only could you see in a company, but we could do on a day-to-day basis. Again, nice. I'm seeing people using that finite word a lot when using to answer A, which is very good, very, very good. The challenge. So let's just take an answer here. It's a chemical reaction, which means it creates chemicals and has a dangerous effect in the environment. Ah, notice how we don't use that word. People seem to forget about it. It's not a chemical that it's necessarily producing. What gas is being produced with the use of displacement reactions? Good, well done, Alfie. Straight in there, carbon dioxide. Now, how might that impact the climate? What two things can happen? Climate change. And what is climate change caused by? Good, global warming. Nice. Yeah, good stuff, guys. Some really, really good answers there. I've been really impressed. This is the end of the lesson. What I will say is if you do have any other questions, feel free to stick around. I'll try and answer them to the best of my abilities, just in general. Yeah, things like acidic rain, nice. But yeah, thanks for sticking around. I've been really impressed with the caliber and quality of the answers, and hopefully I'll be seeing you guys soon for another lesson. But that is the end. Have a lovely day, stay safe, and keep it up. Goodbye.